So what we do is we help governments, banks, companies collaborate where we can leverage the data that they all hold to derive much more insight and ultimately assess risk so that we can find who fraudsters and the criminal elements are. We do it without any sharing of any data. We do this using cryptography, things called zero-knowledge proofs, multi-party computations, and a new one that we've created called permissionless computation. Ultimately, it's what we're trying to create is the plumbing for Web3 where data can move through the ecosystem and people can build tools to use that data to create really powerful applications that are going to make a difference to people's lives.
You have just heard from Rob Leslie, founder and CEO at Sedicii, and co-founder and president of Nillion, one of Ireland's most well-known technology entrepreneurs. Rob started working on zero-knowledge proofs in 2011, and founded Sedicii in 2013, with the aim of creating the world's first distributed, public utility to facilitate the storage and processing of all kinds of data without the need to expose or share it, thereby protecting the privacy and confidentiality of the data. A true pioneer. So let us dive right in.
Good evening, everyone. Rob Leslie is my name. I'm the founder and the CEO of a company called Sedicii. We're based in Ireland. I met Norbert, I think, 8 or 9 years ago in Europe, and it was a complete random note, I think, on whatever day last week. So I was coming to Japan as part of an EU trade mission and said, would I pop by and give you a quick introduction to what we're doing? So I'm going to take 20-25 minutes or so, introduce you to some of the things. Some of this stuff is pretty far out there in terms of its novelty and its innovative components. But I'll just give you a quick intro to the core of our business, which is all around digital ID, KYC, know your customer, and anti-money laundering checks, but done in a collaborative context, where no single institution is doing it on its own. It's now doing it as part of a network. And it's leveraging the data that each institution has for the benefit of the whole. You might say, how on earth are banks doing that? Because their data is extremely valuable to them, and they don't want anybody else touching it, seeing it in any way. And this is where the magic of the cryptography that we've created. So there's one economy in the world that is booming right now, and it is the criminal economy. It is growing in double digits. It's the third largest economy in the world. It's going to probably exceeded $6 trillion last year, and it shows no sign of slowing down. And this is one of the things that governments are extremely concerned about, because every yen, euro, dollar, whatever, that goes into the hands of the criminals comes from hardworking people who've been defrauded, scammed, whatever, and have lost from a few single-digit dollars to their life savings because they believed and were tricked into doing something that they will regret probably for the rest of their lives. So what we do is we help governments, banks, companies collaborate where we can leverage the data that they all hold to derive much more insight and ultimately assess risk so that we can find who fraudsters and the criminal elements are. We do it without any sharing of any data. We do this using cryptography, things called zero-knowledge proofs, multi-party computations, and a new one that we've created called permissionless computation. And these are cryptographic protocols that allow organizations to work together in a way where there's no sharing, no exposing of any data, but the data acts as if it's pooled, but it's not. And it's the foundation of what we think is going to be Web3, because you now have any organization potentially able to use the data of any other organization without actually having it, holding it, or seeing it. And you might go, how on earth do you do that? There's a bit of magic in there, but that's what I'll get into in a second. So we have a platform today that does digital onboarding for companies. We identify individuals and corporations. We have connections to registries, official, authoritative government data in over 130 countries, where we're able to retrieve the actual identity of a company and who the people are behind that company. Not every country is equal. Some of you get very good data, and some of them you get rubbish data. Some of you get nothing at all, because that's where they make their money. hiding that information. But whatever we can get, we get. We use a platform, a tool called business process modeling and notation that allows us to build very easily complex business processes by essentially dropping in modules into a sequence. And so that if somebody says, I want to change my business process, I just take a module out of the sequence and I drop a new one in. It's graphical, so it's very easy to make changes. There's no coding involved, which means we can deploy a change very quickly. And we now want to move this into a space where I can integrate this with other organizations. So creating collaboration between organizations so that they can share their data with all of the controls that you might want to have around that in terms of privacy and security and all of the necessary tools that make it effective and useful will all be part of the platform. An example that we're working on right now is helping banks fight money laundering and fraud. A very simple fraud that is probably costing 6 billion around the world today, is where somebody gets tricked into paying money to a person they think is legitimate, and lo and behold, when the money goes, they find that it was actually paid to a fraudster to a bank account that had no bearing whatsoever to the individual they thought they were paying. And the solution to this is really easy. If I could ask the receiving bank, I think I'm sending money to Michael Murphy and his bank account is 12345. Does Michael Murphy really own that bank account? And if they could say yes to me or no to me, I could stop it at source, because I now know that I'm paying money to somebody who is not who they claim to be. But today, the banks can't do this. What we enable with the cryptography is the ability to query them cryptographically without seeing or touching or them having to share their data and getting a result back that says there's a 100% probability based on the question you just asked that the answer is wrong. And that's all I need to know, because I can now stop the transaction and I can stop it at source before the person has lost their money. Banks should love this because they now have extremely happy customers because you just saved them a bundle of money. A little bit about us, we're 9 years old. We have a number of patents pending and granted. We won a bundle of awards over the years for the innovation that we've been working on. The one I'm probably most proud of is being named by the World Economic Forum as a technology pioneer. It puts us into the class of Google and Facebook and Twitter and all of the glitter app of Silicon Valley. We've got a little bit to go to catch up on some of those guys. At least we get to sit in the same room and shake hands with some of the CEOs of these companies, which is a bit of fun. I'm going to talk a little bit about messageless computation. This is the new cryptographic protocol that we've created that enables the non-sharing of data that others have and you have within a net. And we think it's going to change how data is stored and processed, potentially globally. A little bit of context. Web 1, the first iteration of the internet, when it came along, everything was centralized. And it was centralized in a way where you couldn't interact with the server that you were doing something with. It was read-only, essentially. Along came Web 2, and we now have the ability to interact. We could send information to somebody, we could receive an answer back, but still, from a storage and processing perspective, the information was still centralized. What Web 3 promises to deliver to us is a world where I can now send, store, and process information in a fully decentralized way. And what I mean by storing and processing stuff is truly being able to process data that's held on multiple servers at the same time. And I'm not talking about copying data from one place to another place and reusing it, which is what we do today. It's a kludge, and we just see a proliferation of the same data in hundreds, if not thousands of places. That's not what I'm talking about. I'm talking about leaving what data you need in one place, being able to combine that with data from other servers that other companies and other organizations own. A KYC check might be a bank has some data, the government has some data, maybe an airline has some data, a telco might have some data. I want to combine all of that to make sure that you are you, and then I'll authorize the transaction and it happens instantaneously. Multi-party computation is the cryptographic protocol that this came from. And what multi-party computation allows you to do is to process data held by different organizations in a manner where none of the organizations learn anything about the data the others have in the computation. So all of us in this room could have data. we could all contribute something. Let's say I want to calculate the average age of everybody in the room. We all input into that computation our age, and boom, out pops a result that says the average age is 25.3. Nobody in the room learns the actual age of anybody else. You just get to see the result, right? And that's useful from a privacy perspective because I can now keep my data private. I don't have to share it with anybody, but I still get to get access to the data that everybody else has. Problem with it is it's slow. When you have complex computations, they grind along. They can take minutes to hours to sometimes days to compute when they're complex. And the reason for that is that all the nodes have to talk to each other. They're not sharing data, but they're communicating. And they have to communicate in a sequence. Every communication takes 200 milliseconds, a network interaction essentially. So multiply that by millions and millions and you can see why it takes a long time. Our innovation is that we've eliminated the need for all of that communication. Essentially what was happening between all of the different nodes in the computation is now happening inside a microprocessor. So it's executing at CPU speeds. So it's gigaflops rather than 200 milliseconds per interaction. And what this means is you get an improvement in speed of anything from 1 million to 1 billion times faster, which makes computations that were previously non-feasible. Another thing that it solves is this, what's known as the blockchain dilemma. Essentially, the goal for blockchain is to try and achieve growth of all of these three vertices at the same time. I want to have greater decentralization without compromising security and being able to scale really quickly. Generally what happens is you can have two and the other one sort of falls away. I have better decentralization and more scalability, but I suffer on the security side. We think we've solved this problem as well, so that you get this balloon effect where the three vertices expand together. The method of doing this, essentially, like all great inventions, came from putting two pieces of currently existing crypto protocols together, rather than just using one. We took the best parts of both, combined them, and suddenly realized, wow, if we put these together, we can actually make this whole thing much, much faster. And it's got applications in all of these different areas. Encryption, a data bank for the metaverse, so that we now have the ability to store information in a completely decentralized. So an example of old SMPC, so I take my private key. If anybody here knows crypto, and if you do, you know that your private key is the magic key to the kingdom. If anybody steals your key, they're going to potentially steal your crypto, and you're going to lose whatever is there. What SMP allows you to do is to take your key and break it into pieces and store each of those pieces on a different node, so that I can still process a transaction by signing it with my key, by running a computation that takes each piece from each node, combines them to sign a transaction to say, this is me, I'm authorizing whatever needs to happen. It's slow, but it's sufficiently fast for the world that we live in today. What we've done is we've made it really fast, so that you can execute this at scale for lots of transactions and combine it with other things. So for example, if I wanted to move Bitcoin from my wallet to Ethereum and I wanted to put something in Solana, I could sign a multi-party computation with 3 keys, all distributed across the network at the same time, with one master key, if I wanted to do that. Yet, no single organization has access to the entirety of that information. I'm the only person who can do that because I have the magic fingerprint or facial biometric or whatever it is I determine is critical to the authentication process. A very simple example that I use to explain what multi-party computation is a very simple thing like a credit card. So today on Netflix or Amazon, when you want to buy something, typically most people will have a credit card stored on file. That credit card will be encrypted, but it will be stored on a single central server. That credit card information being broken into, say, 10 pieces, a little bit like a jigsaw puzzle. And I store each piece on a different server. I can still process my credit card payments without ever recombining each of those pieces from my jigsaw puzzle together. So nobody ever sees my credit card information ever again. And what this does from a cybersecurity perspective, it completely changes the risk profile of the data. because now a hacker has got to steal data from 10 different places rather than one, and the data itself has been transformed into something that is non-readable. It doesn't make any sense unless you can reverse it, and that's almost impossible. I'll explain why in a second. We use a mathematical transformation process when we take to turn it into something that's known as information theoretically secure. And information theoretically secure is a one-way mathematical transformation that you apply to a piece of information that turns it into something that might be hidden in a vault to the equivalent of ash. How do you take a pile of ash and reverse it so that you get the information back? You can't. It's impossible. And that's what we do mathematically to the data. You can't reverse it. Yet it still has meaning to the cryptographic algorithm that needs to process it. Pretty clever, actually. So we come back to the speed of this. We've now figured out how to scale this and how to do it really fast. So information theoretic security, we've got speed and scalability up to 1 million or 1 billion times faster. From a decentralization standpoint, we now have a network. Let's say we've got 1 million nodes in this network, where I could have thousands and thousands of transactions happening in parallel that all use randomly different nodes in the network. They're not queued like the Bitcoin blockchain. It's not sequential. They can all run in parallel. If I wanted to write something out to a blockchain, like Ethereum or Bitcoin, as a proof that I did something, I absolutely can do that. But that's not what we're aiming to do. What we're trying to do is to get decentralized storage and processing running at scale that's highly secure. And if we want to add in sequential sort of proof that something happened at a point in time, we can write it to a blockchain somewhere and we get that proof that it happened on this date at this time, the evidence is there. So what does this mean for crypto and for others? So we're thinking about storing keys or any other cryptographic evidence that you may not want to put in one place. You can now shred it and store it in this network. You know where it is. It's sitting in 1 million haystacks, and you know which ones, but nobody else does. So if someone wants to come and steal your magic NFTs, they're going to have a really hard time trying to do it. Private key storage, decentralized signing, and I'm talking about biometrically enabled documents. For years I've been aghast at how we sign documents digitally. I send you an email and I drop an image into that is the equivalent of me signing something. I've signed documents for other people. I shouldn't admit that, but I have. Why? Because they told me, get into my email, download the document, and I put a squiggle in it, and everyone believes that it's real. There's no legal binding to the person. Now, you could sign a document with your face or your finger, or a combination of your face, your finger, device, location, time, all of these different things very easily. That will absolutely link it to you, and only you. Nobody else can impersonate. Authentication, passwords. What if we could store passwords in a network where they were fragmented so that nobody could actually steal them? Hallelujah. That's where we started, actually. That's where Norbert and I first met, was using zero-knowledge proofs as a mechanism to improve how password authentication worked, so that you didn't have to share your password in the act of authenticating. As an interoperability layer for all the different chains. What if you could, again, create computations that allowed you to interact with Bitcoin, Ethereum, Solana, whatever, all at the same time? Fast. That'd be hugely useful, because today anybody who's traded crypto knows how clunky the whole interface is. It's awful. And if it's going to become mainstream, I don't think Bitcoin maybe is going to be mainstream, but there will be tokenized implementations that will take all of that nice tech and apply it to real-world finance to do different things. Why? Because it's efficient and fast and cheap. But these interfaces have got to get fixed. Talked about multi-chain wallets, DAO tools, private metadata, interoperable data, scaling, private smart contracts, and the list goes on and on and on. There's tons of things in here that we think that the technology could be applied to that makes them more scalable, more secure, and more decentralized, more robust, because it's got embedded redundancy and all these nice things in it. It's not just about crypto. We think potentially you can apply this to billion-dollar industries that exist out there today. and make them safer. Talked about distributed storage of password, taking out a LastPass, 1Password, whatever it is, where you've got millions of passwords all stored on a single central server. Oh, that's terrifying. The damage that would do if somebody was able to hack into that and steal all that information. And it's one password probably away from happening. But if the information was distributed where no single piece of information was on a single server, it was distributed across a very broad network, you could eliminate that. One that we've had a lot of inquiries about is healthcare and drug discovery. Being able to process DNA, for example. Legally, you're not allowed to send DNA outside the lab that holds it in many countries. But if I could run a multi-party computation processing this data in a manner where the data stays where it is in each of the labs, I would be able to do a ton of new research on cancer drugs that potentially now access all of this type of data. And there's much more. We know how inefficient governments are. Government departments don't communicate well. But again, you could now build technology that would allow access to government department data without them having to share or expose that data to anybody else. So they can still have their walled garden and their siloed data, but I'm still able to extract the efficiencies that I want as a citizen from that data. We want to build, or rather Nillion wants to build, Nillion is the company that we've licensed the core technology to, an ecosystem where developers are able to take the tools that will be built for them to create their own applications. They could be on the crypto side, they could be on the real world business side, doing a whole range of different things in any vertical that potentially becomes useful. And we've got all of the wallet stuff, smart contracts, the metaverse, then in the business world, you've got biometrics, I think is a really interesting one. Governments around the world are terrified again of biometric data being stolen. But if I could take my facial template, for example, and break it into 10 components and store them on 10 random servers in the United States or in Europe or in China, wherever the government determines is appropriate, that is a much more secure way of storing that data. So it eliminates, I won't say eliminates, it massively reduces the risk. By building consent on top of that, somebody wants to use that template and they need my permission to do it, I can do that. So I can walk into a baseball game or football match, whatever, camera recognizes me and I've given it advance permission to process me, so I don't have to take out my ticket and stick it in the machine. My face is my ticket and I just walk in. But it only happens with my consent. So it touches everything, businesses, governments, consumers. And what we're trying to do with Nillion is to create this buzz in the community where the developer world starts to see the possibility by taking what really is building block technology that nobody really wants to dive into the maths and understand what's going on. It is plumbing, right? Can anybody see the plumbing in here? Nobody can. It's in the walls. But we know it's there because the water comes out of the tap. Ultimately, it's what we're trying to create, is the plumbing for Web3 where data can move through the ecosystem and people can build tools to use that data to create really powerful applications that are going to make a difference to people's lives. So I hope that was useful. Happy to take any questions that people might have.
Maybe purely from a business perspective, so we spoke about this first 8 years ago, and so maybe in hindsight, you were very early on that topic, and maybe too early on being able to commercialize it. And so when you're now talking about Nillion, what is your confidence level of saying this is now the right time it will actually take off?
That's a great question. So I started working on zero-knowledge proofs in 2011. Nobody knew what they were. I didn't know what they were, but I thought they were cool. So I spent the next 5 years experimenting with building these, trying them out, entering innovation competitions to see, does this feature? Do people think what we're doing interesting? If they do, we'll get to the last round and we might get to the final and we might win something. There was a period where we won every competition we entered because people thought what we were doing was really cool. And then time shifted again. And biometrics became the cool thing and we just didn't feature at all. So timing is absolutely critical to the success of what you do. Trying to get that nexus of things coming together at the right moment that gives the spark to whatever your idea is to set it off. It didn't happen for us with authentication, but we just kept plugging on. So the message I'd give to every entrepreneur in the room is persist, right? There will be a moment where whatever you're doing does matter. And you've got to be around with your product when that. Make your runway, make your cash runway last. We've been really good at doing that. We waste money on nothing. We're mean when it comes to spending money on little things. If we can get a cheaper version of something, we will. Reviewing cloud costs, for example, because it changes every month. New tools come out that allow you to do things in a better, faster, cheaper way. And 10 grand one month could be 4 grand the next if you use a different tool. The other thing that I've learned over the years is that building a business is a little bit like baking a cake. You've got to have the right ingredients in the right amounts, mixed together for the right amount of time, in the oven at the right temperature, for the right amount of time. If you do all those things in the right sequence, you're going to get a great cake. If you do any one of them wrong, your cake is going to be rubbish, and no one's going to want to eat it. So it's about getting those things right and in the right sequence for the right length of time and so on. Now, one of the things we sucked at, and we still suck at it, is selling. We are commercially no good. We're technically brilliant. So again, getting the ingredients for my cake was finding guys who are commercially really good. So the Nillion guys are marketing geniuses. They know how to create a narrative, build a story, create a bit of hype, a bit of fun, FOMO, all of these things that suddenly everybody, oh God, have you heard Nillion? You know what they're doing? It's amazing. It's building that community that thinks this is the next best thing ever. And these guys are masters at it. They're also extremely good at raising money because they're able to tell a story. The quality of your story determines ultimately how much money someone is going to give you, because they're going to believe you if you're really good at it, and all of the other things that need to go into that. I realized that we didn't have the skills to do that. So I found, it wasn't overnight. My first interaction with them was in 2017. So we were going to do something when the big first ICO boom happened, and we decided no, it wasn't the right. Technology wasn't quite right, things went quiet, and then last year, in I think it was February, we picked up the conversation again, and I said, you know what, we've just come up with something really new and cool. Explained it to them, and they went, wow, that is cool. We can build a story around that. We can raise a bucket load of money around that. Ultimately, we're going to list this on an exchange somewhere and make a bucket load for a whole lot of people. But for me, personally, the bucket load of money doesn't excite me as much as making a difference to people's lives. And it's partly because I'm at the stage in my life where the excitement of money, I've had it, lost it, it didn't make me happy. What I get more satisfaction out of now is creating a product that makes a difference to people. Seeing a lady who doesn't lose her life savings because we produced a product that allowed a bank to say, this guy is a crook, and she gets to keep her money. That makes a difference to me. And as long as my head is a little bit above the financial level of the sea, I'm okay. When I start to go underneath, then I'll care. So far, so good.
Me following on from that, obviously, good luck with Nillion. That sounds great as the direction. But also when we look at different countries and how they adopt digital technologies, big countries like Japan can be really slow at times, at least feels to us like that. And then smaller countries like Estonia or Singapore are, say, only like a few million people, really pushing the envelope on that. And so does that play a role in your considerations? Have you had conversations with Estonia, Singapore, saying you're already doing, like Singapore has a SingPass, they have data sharing for the government already, now putting that technology underneath would make it so much faster and safer, and they might be nimble enough to actually have the conversation for 4 million people rather than 120.
I've been to Estonia, I've spoken to the Estonian team that built X-Road, for example, and came to MAS in Singapore. I've had conversations with them. You would think they nailed it out of the box. They didn't. Both of them have screwed up times along the way, but you don't hear about that because they don't want you to hear about it. They have a willingness to try and fail and try again. So they're constantly iterating. And I think that is one of the key factors in any successful economy. is you've got to keep innovating. I remember having a conversation with the chairman of the board of one of the biggest banks in Spain, and he said to a group of us, he said, if you're not innovating faster than your competition, you are becoming obsolete. And when you tell people you're becoming obsolete, they go, no, God, don't want to do that. But you can still be innovating and become obsolete because you're not going fast enough. And I think Japan has fallen into that place. It innovates, but it doesn't innovate fast enough compared to the other countries, and consequently, it is becoming obsolete. Slowly, but it's like boiling the frog. Little by little, he doesn't know he's in the hot water until he's dead. So my advice to Japan is you've got to up the tempo. All of the other things that you need in this country are here. I lived here for nearly 20 years, earlier in my career, and money is here, talent is here. All of the parts that you need to create a successful innovation economy are here. You need a spark, and you've got to find that spark and then publicize the hell out of it, because that will attract more talent. More talent will attract more ideas, more companies. And you start this chicken and egg cycle that just keeps expanding and growing and growing. And I think that's what Japan needs to do. And it can absolutely do it. Absolutely. Throw some money at it. That's where I would start. Great.
I think,
Thank you very
thanks,
much.
Rob.